How's it going, everyone? Welcome to another video on the advanced Redux. And in today's video we're going to take a look now at the createReducer. This is part of the series of videos from this course taught by Steve Kinney, head frontend engineer at Temporal. We're now looking at this advanced Redux, which is this well-parallel test state management library out there. So the whole point of this is to understand is what is the value proposition of this Redux RTK, right? Because initially we're going to look at, so far we have looked at how do we get here, right? So by understanding what JavaScript is, what it does, how it's working, what are now the things that we can do with this particular language, especially to build these model web applications, and how can we use some of the previous ways to organize data and its functionality with the object-oriented programming, and how we can use this paradigm as a way to build this application when it comes to actually communicate to other computers, which is one of the powerful things of building all of these model web applications, is that they have a particular mechanism or way of doing things that allow us to perform this. And not only that, but to build them in a maintainable and a sustainable way. So that's what we also look in JavaScript, is the async nature of that. And how do we get to look at that async nature? What are the mechanisms and the particular objects that we can use? So then we look at React. What is the value proposition of React? What are the problems or challenges that we're facing, especially when we building React applications, and how we can come up with some solution, or the community come up with some solutions based on a particular way of doing things, or an architecture of doing things, of building things. And that is the Flux architecture. So because back in the old days we use this MVC, which is something that you're still using in some of companies, right? But when it comes to actually is now building these model web applications using the latest features that the web technology provides you, HTML, CSS, and JavaScript, and how you can make that in a way that is sustainable, it is maintainable, and is scalable, right? So that's why we are here, by looking is that this Redux is this particular way of how can we organize our applications in a way that we know and we can make the states or the data or the models maintainable and testable over a long period of time, right? This is state management. So so far we're not going to see how can we create our own reducers, even though that now React 18 actually provides you this convenient way. These reducers this Redux is just a simple function that takes it in a state and an action to generate a new bit of state. And the idea of this is instead of actually mutating the objects and with that doing some rippling and unexpected effect through other applications, when you generate a new state, you make your application in a more predictable state, right? So so in this course, what we're gonna see is that how can we use Redux with TypeScript, as well as the Redux toolkit, the Redux reducers, and when it comes in our applications to talk to external or to talk to other servers from React, React has a particular way of how you can handle that, right? And how React actually allows to describe the UI, and then how you can now add interactivity. So then you're going to see how you can manage your states and some of these escape hatches, which is the way of how you can now perform some things outside of the normal UI or outside of the normal React, which is how you can now interact with other elements in the browser for any other API, or how you can communicate with external assistants, right? Using effects. And how beautiful it is to understand this deeply, because now you can not only be able to describe it, which is something important as a soft skill, but also to solve the problem quickly and understand what is the problems that now each one of those approach are trying to solve. In this case, with the effects. So because of that, it has also a particular challenge known as the duplicate request, or catching waterfall cascade. And this is something that happens especially when you are adding all the more components that in your three components. If each one of them are actually fetching data, what happens is that you're going to create these cascade effects through your entire React application, which of course will slow down your application. And also is then you need to deal with race conditions, especially when your user are typing a lot of things behind the scenes, or when you're searching for something and you need to have some sort of trolling or debound as a way to handle that, or to prevent these race conditions. They also provide you a way to do that. So with that, right, which to me is quite interesting. Because now that we look at that, right, and we were talking about how can we now is doing that. So Redux RTK actually provide you that allow us to do this. Okay, one of the things on this course, which is pretty short, actually it's not that long, as you can imagine. You got introduction, Redux toolkit, type hooks, and asynchronous requests. This introduction is describing is what are the problems that Redux are solving, okay? Especially the advanced, what are the problems that Redux solve, and what are the challenges that we are facing when we're using Redux, okay? Because if you want to have now, if you need to have an state management, right, as a way to organize how all of these particular states are going to be updated in your UI. So we need a way to make that predictable, and also to make that predictable, easy to test and maintain, right? So for that, we have something that I already mentioned, which is the reducers. And what happens is that anytime you want to create now an state that can be shared across different components, and update that appropriately, so we can keep track of what's happening behind the scenes using the flux pattern. A lot of the time that requires a lot of ceremony, okay? Or a lot of the time, no, that require a lot of ceremony, because you need to define is certain things that is required for this flux architecture, okay, the things to build this state management, which is you need to define is the actions, all of your actions possible in a const file. Then you need to define your reducers, which is what are the what are the new bit of a state that it will generate based on these actions, okay? And then you need to actually define your initial state, right, or your state that will be modified, right? So as you can imagine, there is a lot of ceremony. This is just only to define one state that will be shared across other components. So for example, user. As you can imagine is that if you have, for example, if you're building an e-commerce where you have now the users and the orders and the history, say order history, and the and also if you want to keep track of what is the analytic of these users, as well as the payment history, the more state that you need to define here, the more models that you need to define, the more information you need to define on each one of them. Now it requires a lot of this ceremony only to set up. And also when you need to define is a new type of action that the user can allow this, or in this case to enhance the features of this product, then you need to actually define also the same step or this ceremony that you need to pass through that. So this is one of the things that Redux is solving, right? So it requires less ceremony when it comes to not only defining, say, model of the data model that's in a state or information that we want to keep track of, but also when we want to enhance what are the operations that we can act on this data, we reduce the amount of ceremony. So we already have this, we automate that process. That's one. The other is that when it comes to provide TypeScript support, is quite troublesome, which means that you require to go with using these arcane types that a lot of the time you wouldn't be able to use that, or it requires you to use all of this arcane TypeScript, and this is not well supported. So now Redux RTKey actually provide a better TypeScript support for that out of the box, which is great in terms of not only make our code easy to read, so we can also look at the author intent. So error happen at real time, not at runtime. And also one of the beautiful features that I like too is we have this now auto completions provided by ID like Visual Studio Code, where behind the scenes is running is this LAN server that is gonna check for error. Is checking for errors per file, and that's pretty powerful. And also it also allows to all of this, so writing files in TypeScript, it puts all of these guardrails in your code so others can know how to use them. So yeah, and last but not least, when it comes to actually now perform this data fetching, when we need to do the data fetching, a lot of the time is quite problematic, especially when you need to keep track of the different state that this data can be. So for example, like it's loading, it's on error, and that kind of thing. And not to mention that when it comes to add new functionality to your Redux, it's something that you need to look out for a lot of Google. So you need to Google all of that kind of things. Usually, most of the time, only just to add is a simple or to extend a functionality from this Redux, right? So, first thing first, we look at wait, what? Okay, so this is the pain points. So we identify as the pain points of Redux, right? So update or state without too much ceremony. Okay. The other is that adding middleware to that into our dev tools is something that you need to Google a lot of the time, and it provides TypeScript support. This is how the exercise is organized. Here we're gonna see how to work with related models, okay, with Redux, and I think that's something interesting. And then we're gonna see how you can use it with TypeScript, again, to use some of the utility functions that TypeScript provide for us, and then the asynchronous request with RTK query and that kind of thing. So, as I mentioned, we look at so far is this Redux toolkit. It's like, what is this create slides, which is just a function that takes the initial state, the reducer, the name slice, to generate is now actions, to generate automatically create actions, action types, reducers, as well as the state for that. So we need to look at what are the couple of things that it generates as a way to understand and to make sense of what is all the heavy lifting that it's doing for us. So create actions here, right? So after all, this create action is just a function that automatically create not only types, action types, but also is the object with the type and the payload, right? So that was not that hard to do that. In fact, it's pretty straightforward. Okay. And yeah. Okay. We also use some of this particularly interesting TypeScript support. That is, well, what it is? Yeah, that is what is it? Yeah, this is the example, but I want to take a look now at there you go. This is just to look at this, right? This is create actions, okay? Now this is exactly, and there you go, right? This is now the particular file, the initial file, right? And how you can transform this. With all of the create actions. Makes sense. Good. I'm going to remove this. Right. So let's migrate actions. Okay. Well, let's migrate let's migrate actions and reducers to Redux, right? But first, let's start with actions, right? Actions. Yeah, that's right. So this is our initial file, right? Initial file. We can call this counter reducers, counter reducer.ts. All right, and here we got is the counter reducers, right? With create actions. All right, so far so good. No, nothing fancy there, is that? And no, is this not? And this one. Right, exactly. The exercise, the actions, and that kind of thing. Right, create counter with create actions. So far, so good, right? If you're not familiar with this, you are gonna look like say, what in the F is this? You know, what in the F is this? But yeah. So as you can imagine, it's actually creating is this as expected, right? It takes the first argument, this create action, it takes the first argument with that, and the second argument is this function, this callback function that is going to generate is now the payload for us. As well as this create action generate is the type for us. Great. Awesome. Awesome.
Like, why not?
And in today's video, all right, we're gonna take a look now is at the create action, create reducers, and then we're gonna dive deep into the type hooks. Okay. So create reducers, right? Create reducers. There you go. Okay. Good.
The other kind of piece that we can use is create action sibling. So now we're going to talk about createReducer, which is, if you saw in that slice before how I just had the properties on that slice, and you want to just pull that piece as well, you can have that too. It's all yours. And
What?
the other kind of piece that we can use is create action sibling. So now we're going to talk about createReducer, which is, if you saw in that slice before how I just had the properties on that slice, and you want to just pull that piece as well, you can have that too. It's all yours. And mix and match whatever you want. Regular actions will work with createReducer. Create actions will work with a regular reducer. It all can work together for you. Which is, if you saw in that slice before how I just had the properties on that slice, and you want to just pull that piece as well, you can have that too. It's all yours. And mix and match whatever you want. Regular actions will work with createReducer. Create actions will work with a regular reducer. It all can work together. It's all yours. And mix and match whatever you want. Regular actions will work with createReducer. Create actions will work with a regular reducer. It all can work together for you. So, like, what would it look like if I just want to make a brand new reducer? So we've got this other idea of like
Create reducer, exactly. So let's going to take a look at the documentation, my friend. Create reducers, right? There you go. So this create reducer, okay, a utility that simplifies creating reducer functions. So this reducer functions is just a function that takes an state and take an state and an actions to generate a new bit of actions. Okay, so that's what a reducer it is. It's a fancy way to. It's a fancy function. But it's just a fancy function that is taken in a state and an actions to generate a new bit of a state. That's all, right? So this use Immer. So Immer internally drastically simplifies how you can mutate or how you can update. It simplifies the immutability logic. Immutability update logic. Because remember, at the end of the day, in React, we need to also generate a new bit of a state anytime you want to update a state. And as we mentioned before, for make the state predictable when it comes, so we know when this. So to make this state predictable, we generate a new bit of a state instead of mutating the object, right? That has been shown for other language and projects that is a losing strategy. It's not a it's not that good. That's what I'm gonna say, especially in Java environments. But in any case, all right. So yeah, it used Immer internally to drastically simplify immutable update logics. What it means that you can write mutable code in your Reducer, but behind the scenes, what it's doing is to generate this new immutable state for that. Let me say that exactly. So Immer is that. And Immer was updated 2 weeks ago. Holy F. But it's that. Create the next immutable state tree by simply modifying the current tree, right? So instead of you having to do that manually, which is something that is quite tedious, especially if you have nested object property, that at the end of the day, this nested stuff doesn't exist. After all, they just only have is reference to that object. So anytime you create now an object that inside of this, anytime you create an object whose value is an object, right? What you're doing is to telling the JavaScript create this another object, or point to that object. Okay, I want a reference to these objects, where the idea here is to you being memory efficient, right? Instead of having duplicates of all of this, you just only have one. You just only have one box, all right, where you put is, for example, your notes, all right. So you leave that in some place, all right. And anytime someone wants to know where is this note, they can just look at this, all right, and say, oh yeah, it's this one, it's this note. Yeah, the note is in there, right? So any other person that wants to look at that information, right, knows where this is, right? In terms of the computer, it is like any time someone wants to access to that information, okay? Exactly. So anytime people actually wants to access to that information, they look at that, at the same reference. So you don't actually is sharing or creating new copies of that. You're actually is having one single reference. This is for memory. Being memory efficient in these terms actually is something that is quite interesting. If you, yes, software has developed over this limitation, right? And this is one of the things that I love about software, that is developed over its limitations. And since I come from a very limited background, right? Initially during my childhood, that was not the case, but as I grew up, then I finally faced that reality that is always there, that our grandparents actually knows that, the limitations of the things. Hey, this is the things that we are, that we know, this is there is a reason why your grandma or grandpa, most of the time, right? They actually store that. They're preppers, right? They have this in case of, because of that limitation. And software actually have developed that, and I learned that from the hard way, how you can do it. So, because that has shown that is a quite complex strategy, especially if you want to maintain something. And since the memory cost has reduced dramatically thanks to the innovations and the competition in that field, So now we can use a little bit much more resource in when it comes to actually generate data, or to make the data maintainable, right? So now, instead of actually everybody have one single reference, which means that those people need to actually access to that, right? Now each one of those persons has a copy of that, which is great, okay? And when you need to update that, you're going to deliver a copy to each one of those persons. Some problems emerge, and the problems that emerge is in terms of distribution, right? Is that how you can make now those people that actually have that get the latest notebook, for example, right? And that's one of the issues that actually Redux is trying to solve with this particular architecture. So this is Immer, right? Winner of the Breakthrough of the Year React Open Source Award, and most impactful contribution JavaScript Open Source Award in 2019. Contribute using one-click online setup, that kind of thing, and yeah, it is. Yeah. Used by 10 millions. God damn, this is a country, bro. This is a small country, bro. Jesus. This is a small country. Immer. German for always. It's a tiny package that allows you to work with immutable state. Germans. Germans, bro. It's a tiny package that allows you to work with immutable state in a more convenient way. I'm not even exaggerating. Like, it is right up there with Prettier in terms of, wow, this package is amazing. How did I ever live without it? Mark Erickson, the Redux maintainer. Mark Erickson, winner of the Breakthrough Years. Interesting. You know, Mark Erickson, the Redux maintainers, Redux, right? So all of this is quite connected. So yes, it used Immer behind the scenes internally to make the updates to simplify immutable update logic by allowing you to write this mutable code. So okay, this is createReducer, right? In the context of Redux, okay? So it's using behind the scenes Immer. That's why instead of actually you having to create this, all right, you are going is to Redux reducers are often implemented using switch, exactly, with one case for every handler. This approach works well, but it's a bit boilerplate and error prone. And it's error prone because if you don't define a default case, for example, the createReducer helper streamlines the implementation of such reducer. It uses a builder callback notation to define a handler for a specific action type. Interesting, that is, they call this builder callback notation, pretty much like scientific notations. I want to know is more perplexity here. Provide me a list of the most common notations, right? Notations. Of course, arithmetics. Yeah, but this is most common. Come on, what the fuck? Okay. Basic arithmetic symbols. Comparison symbols, advanced symbols, logical set notation. Wait, really? Mathematically employ a variety of symbols and notation to convey concepts succinctly. Yeah, it's like create a table with the most notable notation. What is a notation? It's a collection of symbols that convey specific meanings. Type of notation: mathematical notation, musical notation, and chemical notation. Okay. Notes on a staff indicating pitch and duration. That's quite interesting. When we talk about notations, is our couple symbols. Okay, we talk about notations. A couple symbols that it's a couple symbols. It's a couple symbols. Yeah, because what is a notations? Okay, here we go with the systems. What is a notation? It's a system of symbols used to represent some information for a particular goal. For example, you got mathematics. You got add, minus, multiplication, division. In the case of music, you have now, I don't know how do you say that. I don't know. In the case of music, you have now a particular notation, okay? The other is chemical notations, all right? So all of these systems, which are set of symbols that represent some information for a particular goal, that's what a notation is. It's interesting. So this is a couple symbols, or this builder callback, which is a couple of symbols to define handler for specific actions. Interesting. So they are handlers for a specific action type. Good. Matching against a range of actions or handling a default case. This is a conceptually similar to a switch statement, but with better TypeScript support. As you can see here, so instead of us having to define is this switch case in our Reducer, which it leads to error prompts. So this help to streamline is the implementation of such reducers. So you get now a builder callback, which is a function that is going to generate that, which is a notation, this builder callback notation, this set of symbols that represent some information for a goal, pretty much like the mathematics. You have the arithmetic, plus, minus, multiplication, division. Music as well. Chemical as well has notations, symbols to represent this particular goal. Similar here, but in this case is to generate or to define handler for specific action types, reducers, which provide much better TypeScript support. So this is a notation that is doing, for example, here the builder. This is a notation. It's a builder callback notation. Okay, it's a builder callback notations to define all of these specific action types. So define the handler action types, like add case or add case for this. Okay, it's a notation here. Add case increment, add case decrement, and then you're gonna pass is now the action for that. Increment by amount. Interesting. The builder callback notation. This function accepts a callback that receives a builder object as its argument. That builder provides add case, add matcher, and add default. So you have this notation that it provides this builder, you know, add a case, add a matcher, and add a default case. Functions may be called to define what action this reducer will handle. So this parameter is the initial state. This is describing is not the reducer, right? The parameter, hey, you got the initial state. Okay, the initial state that should be used when the reducer is called the first time. This may also be lazy initializer function, which should return the initial callback, blah, 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 blah. This will be used whenever the reducer is called with undefined if the state value is primary, useful for case like reading initial state from local storage. And then you get the builder callback, which is the second parameter, which this builder callback notations that it receive a builder as an argument, and it provides some functions to be defined what action this reducer will handle. So for example, add a particular case or add a matcher or the default case for this action creator or type reducer. This is now example of usage, right? In JavaScript, pretty much this. You got now a create action or actions creator or type, and then the reducer. Oh, okay. This action with number payload. You can apply a matcher function to incoming action. Builder add case and add matchers, add default case, and returns. Okay, the generated reducer function. The reducer will have the get initial state and the reducer hook. Counter reducer, get initial state. The reducer will have, return the generated reducer function. The generated reducer function. Okay. The reducer will have get initial state function attached that will return the initial state when called. This may be useful for tests or usage with React use reducer. So it exposed this. Okay. Returns. Example of usage like this. Return type of action.payload is equal to number is action with number payload like this. So you're going to receive is the initial state, followed by the builder notation for defining all of the cases, for defining all of the handlers, that match that action. So you have a case, at matcher, and at default case, and provide a default case if no other handlers matches. Direct state mutation. Okay, here we started to see how you can now mutate that. Because behind the scene is using Immer, Redux requires reducer functions to be pure and treat state value as immutable. While this is essential for making state update predictable and observable, it sometimes can make the implementation of such update awkward. Consider the following example, like this, because after all, this reducer function requires to be pure. Okay, one input, the same output. Given the same input, return the same output. The add to do reducer is straightforward if you know ex6 spread syntax. However, the code toggle to, which is toggle to do, like this, is much less straightforward, especially consider that it only set a single flag. For example, like this, because now you need to get that state slice, you need to get that index, okay, and then append that element in that particular index, and so on. To make things easier, createReducer use Immer. The mutating version of this case reducer is much more direct than the explicit pure one. You say index, it will be, you get the index, you get a to do, alright? And then what you do is that to do to complete it is equal to the to do completed. You switch that. So you're not returning something. Writing mutable reducer simplify the code. It is shorter, there is less indirection, and it eliminates common mistake made while spreading nested state. However, the use of Immer does add some magic, and Immer has its own nuance in behaviors. You should read through pitfalls mentioned in the Immer docs. Most importantly, you need to ensure that you either mutate the state arguments or return a new state, but note both. Exactly, you need to ensure that you either mutate the state argument or return a new state, but not both. Pitfalls: don't reassign the recipe argument. Immer only support unidirectional tree, never explicitly returns undefined from a producer. Don't mutate exotic objects. Exotic object, I'm quite familiar with this. Exotic object. Okay. Exotic object. What does it mean, exotic object? Yeah, what does it mean, exotic objects in JavaScript? Exotic objects. Exactly. What is in common? Definitions of exotic objects. Arrays. Example of exotic object includes array, proxies, string. Characteristic of the exotic object: custom internal methods, behavior difference, and creation via proxies. Exotic object. Example of exotic, so a function is an exotic object. String is an exotic object because it has inner properties similar to this. Bound function exotic object, built-in exotic object internal method. The specification defines several kinds of built-in exotic object. These objects generally have similar to ordinary object except for a few specific situations. The following exotic object can be used to ordinary object internal method except where it is explicitly specified otherwise. A bound function is an exotic object that wraps another function object. A bound function is callable. But for now, I'm gonna stick with this exotic object meaning in JavaScript. Is objects that have unique internal methods. They are objects that have unique internal methods. They are objects that have unique internal methods, right? Arrays, proxy, and strings are like that, entering this realm. Don't mutate exotic objects. Classes should be made draftable or not mutable. Only valid indices and length can be mutating on array. Data not originated from the state will never be drafted. Immer patches are not necessarily optimal. Always use the result of nested producer. Draft aren't referential equally. Here we're talking about referential equality. Draft adding referential equality. What does it mean is that they are not the same space in memory. Oh. If possible, it is recommended to perform the comparison outside the produce function, or to use unique identifier property like .id instead to avoid needing to use original. There's some common pitfalls here, interesting, but this is when it comes to actually is generate a new state for that. You need to ensure that either mutable state arguments or return a new state, but not both. For example, the following reducer will throw an exception if a toggle to do action is passed. So because this is a builder notation that you can either is or return a new state or mutate one. Oh, because you are to do state.index. Oh, you are mutating that. This case reducer both mutate the passing state. Exactly, you are mutating that and returns a new value. This will throw an exception in this example. The easiest fix is to remove the return statement for that. Again, it is particularly functionality. It is particularly way to work with. Okay. You either return a new state or mutate that state. You don't do both. So this is more for this inner function. So behind the scenes is Immer. So writing mutating reducer simplify the codes. It is shortened, there's less indirection, and it eliminate common mistake made while spreading nest state. Exactly. It eliminate common mistake while spreading nested state. However, the user of Immer does add some magic, and Immer has its own nuance in behavior. You should read through pitfall, because anytime you want to mutate the state, it's using Immer behind the scenes. to make things easier, createReducer used Immer to let you write Reducer as if they were mutating the state directly. In reality, the Reducer receives a the Reducer receives a proxy state that translates all mutation into equivalent copying operations. Okay. No. Okay. ¿Y por qué se agarra? Marico, ¿de dónde carajo te agarras, bro? ¿De dónde carajo te estás agarrando, bro? Ok, ya sé dónde. Interesting. Okay, here we go, bro. The Reducer receive a proxy state that translates. Okay. In JavaScript, particularly within the context of state management libraries like Redux toolkit, the terms Reducer receive a proxy state that translates all mutation into equivalent copy, refers to the use of the proxy object in conjunction with Immer library. So is Immer using a proxy behind the scenes? This approach allows developers to work with immutable state in a more intuitive manner. Understanding proxy states in Reducer. What is a proxy? Glad you asked. In the real world, a proxy is someone that acts on behalf of someone, right? Someone that is in the middle. Is an object that wraps another object, the target, and allows you to intersect and redefine fundamental operations. So proxies are used to intersect that. So proxy in the context of JavaScript is an object that wraps another object, the target, that allows to intersect its operations, such as property access, assignment, and deletion. This capability make proxies useful for managing a state in a ways that can track change without directly mutating the original state. Because what it's doing is that since this is the object that I'm going to look, all right, and I'm intersecting. So proxies is like so a proxy is like the bouncer at the database club, right? Okay. Yeah, it's like the bouncer of the database club, right? It intercept whoever wants to get in or get out here, right? Or if you are in trouble, or if you get yourself in trouble, it actually intersects to that. So okay, real life example of proxy, or describe professions. Describe real life profession example of proxy. Yeah, I think that this is the bouncer, a legal profession, real estate agent, professional, but this is professional utilizing a proxy. An agent legally authorized to act on behalf of another party. It's like a representative, remote workers. But this intersect anything. No, but I want us to that's interesting. So you are behind the scene is using as a proxy, which is this native stuff. without Immer, base state dot slide shallow clone the array. Is like, hey, I want to copy from this. Okay, next state one, exactly you create is exactly. So you create a shallow clone of the array. The next one, exactly, you create is a copy of this. You don't have is a reference. You create a new copy of this. All right. So it's pretty much like instead of you having a reference, instead of anytime you wanna access to your notebook here. Okay. So you need to go through that place to actually see that notebook data. Okay. You have now is a own copy here when you have that close to you. Okay. So that's exactly what it's doing here. Hey, let me create now a shallow copy, which means shallow copy. Okay. Which means that let me create now a shallow copy from this. Okay. I'm creating a copy whose properties share the same reference, point to the same underlying values as those of the source object from which the copy was made. As a result, when you change either the source or the copy, you may also cause the other object to change too. That behavior constructs with the behavior of deep copy, in which the source and copy are completely independent. Okay, exactly. So shallow copy, unlike deep copy, okay, what it's doing is that when you create this shallow copy, top level property copy does not affect the source objects, because top level properties has their own reference. So it creates now a copy on that. But but for nested objects, now they have a reference to the original object. Okay. Again, all of these things like copying, cloning, that kind of thing is because back in the old days we have extreme limitation of how can we now and how much data can we store, right? But now recently, well, thanks to the advancement of the technology in memory, now we can make use a lot of resource for. We can make use of a lot of resource to make it much more convenient to work with. But we always has pushed the boundary forward to what is convenient as human, not as a machine. Mm-hmm. The question is that allow for efficient change detection. If this reference to an object didn't change, the object itself did not change. In addition, it made cloning relatively cheap. Unchanging part of the data tree don't need to be copied and sharing memory with older version of the same state. Generally speaking, this benefit can be achieved by making sure you never change any property of an object, array, or a map, but by always creating an altered copy instead. In practice, it can result in code that is quite cumbersome to write, and it's easy to accidentally violate those constraints. Immer help you to follow the immutable data paradigm by addressing these pain points. Immer will detect accidental mutation and throw an error. How do you do that? Immer will detect accidental mutation and throw an error. Immer will remove the need for typical boilerplate code that is needed when creating deep updates to immutable objects. Without Immer, object copy needs to be made by hand at every level. Hey, I want you to copy I want to make a shallow copy from this level, and then from another level, and then from another level, so on and so forth. Yes, yes. Typically by using is a spread operator. When using Immer, changes are made to a draft object that records the change and take care of creating the necessary copy without ever affecting the original object. So it creates a wrapper around this. When using Immer, you don't need to learn dedicated API or data structures to benefit from the paradigm. With Immer, you will use plain JavaScript data structure and use the well-known mutable JavaScript API, but safely. How does it work behind the scenes, my friend? Exactly how Immer works. You have the current. Immer actually have a draft here, and then you get the next object. Using Immer is like having a personal assistant. This assistant takes letter of the current state and gives you a copy, a draft, to jot change onto. Once you are done, the assistant will take your draft and produce the real immutable. Final alert for you, the next state. Benefit: follow the immutable data paradigm while using normal JavaScript objects, arrays, sets, and maps. No new APIs or mutation patterns to learn. Strongly typed, no string-based path selector. And strongly typed is because Immer provides this. Structural sharing out of the box, object freezing out of the box, deep updates are a breeze, boilerplate reduction, first class support for JSON patches. Edge's IO lesson 3, simplify deep updates with Redux. Courier producers. Simplify code by using courier. Passing a function as the first argument to produce, create a function that doesn't apply produce yet to specific state, but rather create a function that will apply produce. This generally is called currying. Passing a function as the first argument to the produce, create a function that doesn't apply produce yet to a specified state, but rather create a function that will apply produce to any state that is passed to it in the future. Okay, so it's going to now, based on this initial state, next state, Immer. And what you're gonna do? To do draft find and then change that and then mutate that. Okay, find that by ID and then mutate that. React in Immer and update patterns. Array mutations, nested data structure. Okay, API overview, map set, classes, curing original patches, auto freezing, returns, create that finish draft, TypeScript flow, best practice tip for current producers, cast utility and resources. But you mentioned here is like how now you can actually detect. Immer will detect that. How Immer is detecting, I think it's with proxy, how Immer is detecting accidental mutations in an object. accidental mutation in an object. Intersection of mutation. The proxy intercepts all operations that will mutate the draft output. Help me to understand how to create a small version of that in plain JavaScript. Exactly. So creating a simple proxy is a first step one. Define the target object, which is, hey, I want to know the name and the age, right? 30. Step 2, define the handlers, which is define a handlers object that will contain traps for the operations you want to intersect. In this case, we'll implement the get and set traps. Create the proxy when you say this is the target objects, and whenever you detect these methods or intercept these methods, I want you to do this for me. Use the proxy, right? And here you say use the proxy. You can now interact with proxy object as if it were the original objects. The proxy will log message whenever property are accessed or modified. So anytime you now say, hey, the proxy object dot name, it will intersect that you have access through that, and just say, hey, getting property name for that. Even though when you are changing that, it also gonna detect that, as well as this. That's quite interesting, my friend. That's very, very interesting. That's very, very interesting. You may wonder, is like, how is this trap are defined? You know? Oh my God. The proxy object enables you to create a proxy for another object. Exactly. Hey, I'm going to create this proxy. I'm going to create this object that acts as an intermediary for any fundamental operation for that object. Description. The proxy object allows you to create an object that can be used in place of the original object, but which may redefine fundamental object operations like getting, setting, or defining properties. Proxy objects are commonly used to log property access, validate, format, or sanitize input, and so on. Exactly. Hey, I want to log his property access, or validate that you get is the okay, or validate that. Hey, I am getting is a proper type that I need to. Interesting. Format. So I'm going to now provide this particular format before actually do some operations, before updating that object, or sanitize inputs, and so on. You create a proxy with two parameters, target and handlers. So we have provided an implementation of the get handlers, which intercept attempts to access property in the target. Exactly. So anytime you define this handler, which is the get, proxies are often used with the reflect object, which provides some method with the same name as the proxy traps. The reflect methods provide reflective semantic for invoking the corresponding object internal method. For example, we can call reflect.get if we don't wish to redefine the object's behavior. But it's for internal objects. The function that defines the behavior that's corresponding to the object internal methods. And object internal methods, okay, it is get property of, set property of, get prototype of, set the prototype of, which is part of the linking or the linking that you're creating, the access that you are at, that you're defining for all of these objects is extensible. And this is all of the inner built-in objects, inner built-in methods. The internal method, get on property descriptor, define property has get, set, delete property, and own keys. This is all object has the following internal methods. Interesting. So this anatomy is something that you must be tattooed as a JavaScript developer. Okay. Get property off, set property off is extensible, prevent extensions, define on properties, has get, the get on property descriptor, but I think get on property descriptor. Get on property descriptor method is a trap for the get on property object, which is internal methods, which is used by operations such as get on property descriptor. Get on property descriptor. It's like, hey, in this object, do we have something called iCount? And it say, yes, we have them. And own keys. It is important to realize that all interaction with an object eventually boils down to the invocation of one of these internal methods. Anytime you interact with a particular object boils down to the invocation of one of these internal methods. Anytime you, boils down to each one of them. Hey, do you have them? Do you get or set? Do you delete this property? Is this belongs to, it has its own keys. Such as in, right? Hey, is this exists here? Icon exists, secret exists, return key in target. Create a new proxy object. And I get it why they use this with the reflect, with the reflect object, because this is a namespace that contains all the static methods for invoking intersectable JavaScript object internal method. Okay, this is a lot of jargon here, but this is just a table of all the methods, this is a table of all of the JavaScript object internal methods that you can intercept. These methods are the same as those proxy handler. Mm-hmm. Mm-hmm. Reflect the delete property for that. Mm-hmm. Okay. We dive deep. We actually dive deep into the realms of JavaScript. So, what is doing this? All right, as a way to actually put this at practice. So, what is doing this behind the scenes, in terms of Immer, okay? In terms of Immer, in terms of Immer is to say, hey, let's go to create an object here. Say, hey, let's gonna call this user, okay? Or we're gonna call this shoe inventory. Yeah, just shoe, right? And here you got now the name of the shoe, right? Say name. Salidas, right? Salida, right? Oh my God, no, below. Okay, so you got name, right? You got also is the size, is the price, right? Say, hey, let's go say $10, right? It's pretty cheap. 30. Look. So alright. So we define this shoe, right? And anytime we want to intersect any interval, any JavaScript internal methods, okay? We define is this handler, which is usually used in combination with the reflect as a way to now do something about it. So once you detect, when you intersect this, hey, I want you is to perhaps validate that entry or provide a particular format. To validate that entry or provide a particular format. Okay? Or to log some property access. Or sanitize inputs. So for example, I can say it's like, by defining is this handler, okay? By defining is this handler, right? That this is an object. By defining this handler that this is an object here, apply construct, which is part of the exactly, is the handler function. It exposes define property, get, and all of this internal, all of this JavaScript internal method that you can intercept that, right? A trap for setting property values, a trap for object get on property. So anytime you want to read about it, anytime you want to have access to, for the in operator, a trap for getting property values, exactly. So you say, hey, anytime, for example, all right, get, anytime someone wants to, set, anytime that someone wants to actually is define here, right, set, right, and this set has now the object, the property, and the value, okay, which contains the object, the property, and the value, all right. Exactly. So anytime we're going to intersect this internal methods. Anytime we're going to intersect this particular anytime we're going to intersect this specific internal methods in objects, okay, like set, all right. So if the props, okay, is equal, so if the props is equal to price, right? All right, I want to see if you're actually is giving me with the proper type, right? You say, is it prop types, right? And I want to say, hey, I want to know, let's validate that. Say, hey, is this prop type of number? Okay. So I want you to evaluate this. If this is not a number, so please return an error, right? You say, hey, no, you can't. Return is an error. Return an error. Say, please provide a number type, right? So why this example is quite interesting, because given the nature of given the dynamic nature of JavaScript, that allows you to change is the value of a type at runtime, which has shown that it's come with its own problems. So this particular proxy object that we're going to create is now, we're telling to the JavaScript, hey, let's going to make things more static. Well, let's going to now prevent these particular errors here, right? So now you say, hey, let's going to create a proxy object like this, proxy 1 and this, say, hey, accounts proxy, or you can say, is this a proxy shoe, right? Proxy shoe, where you say, hey, this will be the new proxy, where you're going to pass the object as well as the handler. You're gonna pass the object that you want to wrap inside of, that you want to wrap with this object proxy to intersect these internal methods as well as the handler. So anytime you say, hey, proxy choose the price, okay, you say price, okay, I want you to now console log this. It will give you the proper value for that. But when you want is to now say, hey, I want you to now mutate that proxy, choose price to 30 to 179. I want to actually is, in this case, do this, price. It'll update that properly. But when you actually now, for some reason, you want to change the data type for this, let's say 79.99, it will throw you an error. Oh. Syntax missing. Oh, of course, I get it. I get it. It says that, hey, it's like, I don't follow. line 10. Missing. Okay. In line 10, there is a missing. Oh, I think because well, this is a set. That's right. So if props price is this one, oh, yeah, you're right. That's right. It's because there is a missing one. Okay. There you got it. Okay. Syntax missing. Let me fix this here. Please, I want you to now run this. And features, that's right. So cd feature list. Okay, so node source features of counter reducer. I want to transform this into a JavaScript file, right? Momentaneously. I know you throw an error. You say it's type of unexpected type of unexpected token here. Prop type of type of JavaScript. Oh, I mean, I gotta do this. Is this prop? It's a type of props. Oh, number? But I don't think you do this. Okay, node is this one. Is a number, that's right. Setter. Interesting. Exactly, the original is being modified. So you mutate the original, which is expected. This is JavaScript doing what it is. This is JavaScript in JavaScript. But here it's not mutating that. Interesting. But now it's mutating. That's interesting. Perplexity. How can I throw an error when the proxy value of price, exactly, how can I throw an error when the proxy value of price is not a number from the following code? Exactly, price is the type of value is different from exactly, the is different from number. It's like, hey, you're gonna throw an error. You're gonna return is an error. Please provide number type. Exactly. Throw new error. And then return the use reflex to set the property of the target object. And then return, otherwise, return that particular value here. Exactly. But it's because of this. That's a very interesting example here. This is a very interesting example because now with proxy, you can not only wrap an object target to intersect specific operations in objects for validating, for logging who is accessing to this property or who is setting this property or what to do with that, or for provide a particular format, which is now the way how this is doing behind the scenes. So Immer is using proxy as a way to make the update, the object in an immutable way, providing you a syntax, providing you a mutable syntax. Okay. All right. Okay. 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 All right. All right. So what you do is with this proxy object, hey, anytime someone wants to mutate you, alright, wait, that's going to do this. We're gonna process these things first. It's gonna process these things first, which is to validate or to log this. So it's going to is provide a format. Wow. Hey, act on behalf of this to detect this. Wow. Instead of not needing to define this particularly Marica, ni c'è un inferno con la mattina, Makes a lot of sense. Parece impresionante cómo está. Igual, para colaborar en el mundo material. Pero para vivir una vida, mano, no. Para vivir una vida, mano, no me cuadra, manina. No me cuadra. No me cuadra. All right. So there is a lot of things going on here, and I think that's great. That's cool. Exactly. Multiple case reducer execution. Originally, createReducer always matched a given action type to a single case reducer, and only the one case reducer will execute for a given action. Using action matchers, change the behavior as multiply matchers may handle a single action. For any dispatch action, the behavior is if there is an exact match for the action type, the corresponding case reducer will execute first. Okay. First is any matcher that returned true will execute in the order they were defined. If the default case reducer is provided and no case or matches reducer runs, the default case reducer will execute. If a default case reducer is provided and no case or matches reduce ran, the default case reducer will execute. If no case or matches reduce runs, the original state value will be returned unchanged. The executing reducer from a pipeline of each of them will receive the output of the previous reducer. So you cannot add a matcher and then your state for that. So if there is any, If there is an exact match for the type actions, the corresponding createReducer will execute first. Any matchers that return true will execute in the order they were defined. Looping draft state values. It's very common for a developer to call console.log state during the development process. However, browsers display proxy in a format that is hard to read, which can make console logging for Immer-based state difficult because it's using proxy behind the scenes. When using either createLive or createReducer, you may use the current utility that they provide that we have re-export from the Immer library. Okay, this utility creates a separate plain copy of the current Immer draft. A separate plain of copy of the Immer draft. And if you remember, the whole point of this, okay, Immer is that you will now, so the problems that Immer solve is that bring the immutability. How you can bring the how you can make the immutable approach. Yeah, how you can make the immutable approach to look like mutable for the developer, for development. Okay. Okay. And that is that Immer will detect accidental mutation and throw an error, will remove the typical boilerplate that is needed when creating deep updates to immutable objects. With the Immer, copy needs to be made by hand at every level. That's right. When using Immer, changes are made to a draft objects that records the change and takes care of creating the necessary copy without ever affecting the original object. So when using Immer, you don't need to learn dedicated API or data structure to benefit from the paradigm. With Immer, you will use plain JavaScript data structure and use the well-known mutable JavaScript API, but safely. This is how it works. This is the mechanism. So you have the current state. Immer, now we're gonna talk to a draft to apply all of your mutations, okay? And generate a new copy of that. The basic idea is that Immer will apply view all the changes to a temporary draft, which is a proxy. So this draft is a proxy of the current state. Once all mutations are completed, Immer will produce a new state based on the mutation to the draft state. This means that you can interact with your data by simply modifying it while keeping all the benefit of immutable data. But this is the problem that they are solving with Immer. How you can make this immutability or this immutable approach in JavaScript to look like JavaScript nature, mutable, okay? And behind the scenes, using in some of the built-in language. Okay, so the problem that this Immer work is, yeah, so the problem is, yeah, so the problem that Immer is solving is how, the problem Immer is solving is immutability data. How you can in JavaScript generate is immutable data, which is using the break operators, and one of the problems with doing that, because if you're going to use plain JavaScript, all right, so what? Interesting, with Flash. So if you're gonna use plain JavaScript, Okay. What happened is that it requires you to do all of this shallow copy per level, right? As well as it is error prone because you can make some errors along the way, as I mentioned. And there is, but yeah, this is the two problems that they are actually solving here. It's like bring the immutability concept to JavaScript, which is a mutable language. Okay, and by doing that, they have now this particular mechanism, another assembly line, where you have now the current, that is when you have your state that you want to mutate or update. Okay, now Immer create this draft, which is a proxy object that is going to apply all of these mutations. Okay, so once all mutations are completed based on this proxy object on the draft, then Immer will produce now this new state or the next state. But it's using behind the scenes is a proxy object, which is a built-in function, which is a built-in object in JavaScript that is useful when it comes to intercept some internal JavaScript built-in methods. So for example, get and set and has a property or delete property. All right. So when is the utility for this is when you want, for example, log that someone actually is accessing to this property, or setting the value of this property. Perhaps you want is to validate when that happened, to actually check that actually you're passing is the proper type to the value, or you want to now give a format to that, which is something that is doing behind the scenes. In this draft object, which is now created by Immer using a proxy, once all mutation has been applied, now we're going to generate this new next state, this new format here. And what is doing Immer is simplifying that particular way of working with immutability here, which is essential in React applications or in any other application when you need to work with immutable data for that. Okay. Exactly. Exactly. Mutable JavaScript data structure with Immer.
In this video course, we are going to study the Immer library. The Immer library makes working with immutable data a lot easier, and for that reason it has become really popular. In this course we are going to go pretty deep. Immer has a lot of features most people don't know about. In this course we are going to build a small application in which someone can manage the gifts he wants to receive for his birthday, for example. And also attendees can reserve the things they want to be giving to make sure that people don't give the same thing twice. And this application will become quite fancy. So it will, for example, be possible to have multiple users working on the very same application. And what's even more, so it will, for example, be possible to have multiple users working on the very same application.
Exactly.
And what's even more, people will be able to do, undo, and redo without breaking each other's changes. And so this whole application will be driven by immutable data, which captures the state, and Immer. However, let's start very simple, shall we?
Exactly, but you are now storing is the state of the application in React as a way to see how you can now work with different models. That's interesting. That's interesting. Yeah, that's completely interesting. Author of the mock state management library, fan of React and TypeScript. Makes a lot of sense. Interesting. Interesting. Very, very interesting. Very, very interesting. Very, very interesting. Okay, so oh my God, that was quite a challenge, quite a thing. Completely, that was quite a thing, man. I was dive deep into this. Okay, so that'll be all for this video. Take care. Bye bye.